So we're back. It's COMP397 and it's week 11. Can you believe it? Lesson 11, part 1. And I want to kind of wrap up some stuff that we talk about the project and give you some new technologies to use to help you build your project up, especially if you're going to make different kinds of games. Like so far we've only been talking about one type of game, kind of a top-down game, and it's taken us all semester, like if you think about it. But some of the same things we talked about during this semester when it comes to game making in general are the things we're still going to use in the future. So if you look at one of the games that I already have up online, it's actually expired. If I look at one of the games I have up online, if I look at this thing called Starbase 12, join me here on Starbase 12. There's version 4 that I've put up online on GitHub. Right? On GitHub, there is a version of Starbase 12 that I want you guys to look at. Now, Starbase 12 is just this one project that I put together a couple years back now, right? Or, well, 7 months ago, it says. It feels like a couple years. Anyways, so if you take a look, one of the things that I have in under scripts, as an example, in my game TS file, if you were going to look at examples of, and by the way, anything that I have on my GitHub is open game. You can use piece parts of what I have up there to make your game work. So I have a couple things that I use. I use some game tiles. That's what I use to make my game function. I have a game loop that I use, right, and everything else. And then, of course, there's our state machine. Here's a big state machine that I have. So remember we talked last time about state machines, right? So I have my menu state, my play state, my game over state, my instruction state, my mission state, my movement state, my defensive state, weapons. These are all different states, and it says subselections of the instruction state that I put into play. So if it kind of new screens, and you can have many of these screens, as many as you want, right? So this is just a bunch of screens that I have. In my play state, that's the state where I play the game. And if you guys remember that game, it looks like a top-down game. I kind of showed you a couple times. All right, so that's one. And if you figure out a couple things, I have in my objects, I have bullets, right? So I have my enemy, I have my flame. As an example, when I made my flame, a heads-up display for different things. I have a loader bar in this game, where it shows it loading. What does it look like? These are all classes that do things, right? Anyways, in my phaser tracer, I had to use the game ability to draw lines. So how did I make this game? So if I go to Starbase 12 and I have it live, so you can look at it, like how it looks right now. And forgive me, I'm not trying to tout the game or anything else. I'm using it as just as an example. So here's my loader bar, and again, I made. If you look at this scene that looks like a screen, I made this screen in Blender, right? That's how I did it, right? So do you guys know Blender at all?
Pro E.
Huh?
Pro Engineer. Pro E.
What do you mean?
It's similar
To what?
It's similar to Blender. Pro E.
What's Pro E?
It's like not more of the animation, more of like architect.
All right. Well, look again. What you have here is you have 3 different objects in 3D space, right? So it looks like it's been, I've taken it from somewhere, but actually I made this, right? So how did I do it? In Blender, if I look at the design here, and again, I also teach Blender for one of my other courses that we do here at Centennial, right? You've got 3-dimensional space, and what we're going to do, of course, in Blender is position objects in different places on the screen, right? So you can easily place different objects, as an example, in different places and create a scene. I'm just going to use cubes for now. You can create a scene so that you can make it with the proper lighting. Here's your lighting. And the proper effects, to create, like I said before, whatever scene you want, right? Right, so there's more different kinds of lighting. You can see that the lighting effects come into play. And this is how I created it. I had 3 objects. I had my camera object, and then in there, when I used different objects, I created this scene that looks like this, right? Just in 3 dimensions. And I took a snapshot of the scene, and that was my first scene. So that's how I did that. again, you can create your scenes in any way you like. So I have this start button. If you notice, it's exactly the same mechanic I've been showing you all semester, right? So the same thing. If I click the start button, get the sound, right? Instruction state with a bunch of states and the play state.
Entering sector
One thing I want you to notice is this,
0.1.
right? I'm just going to turn the sound down so we can. If you notice a couple things, right? Over here, he's getting hammered. The main ship here, my green ship, is getting hammered, right? And he's getting into the shield. So let's take a look here. Bang, 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 bang. He's getting killed. He's going down to 20, and then all of a sudden, boom, right? He's got the end screen, right? Now the end screen, this is kind of what you want to do, right? In terms of thing, is just particle physics, right? It's just particles that come up, and it makes almost like the explosion, right? If I play this again, let's take a look at this again. He's going to fire against the starbase, right? Because the starbase is closer to him than my ship, right? That's the mechanic I built into it when I programmed this thing, right? So again, if you notice, he's firing against this thing, and he's going to keep firing against it and break the shields. Now the starbase is rotating, so the shields, which have different states. There's the full state. And this is when it goes red, as an example, then it's down, right, or it's close to being down. And then it keeps firing at the main ship until it rotates to the other side. Now this, you notice he's been damaged, the main starbase. My goal in the game is to defend the starbase. That's what the whole game is, right? So I'm going to turn, if I turn my ship around, right? If I fire my weapons, right, it looks like it's some kind of ray, right? It's not really a ray. It's not really a ray. How could I use a ray to kind of go in and to destroy a ship? I can't do it. It's impossible. So what I really have in the background to make this thing is, I don't have a ray, it's a bunch of invisible bullets that come out, right? That stream along the same path as the ray. Super fast. So that it looks like it's the ray, but it's not really a ray, it's a bunch of bullets, right, that come out. So I come out and I kill the ship, but really what I'm doing is I'm shooting a bunch of rays at the shield, right? So that's what it is. So really, what I'm shooting, when I say phaser tracer, if you know Star Trek, I shoot phasers. This is a phaser, right? A phaser beam or whatever, like a laser beam, right? But the thing is, what's happening is, I'm actually shooting bullets. I'm not even defending myself. I'm moving here. Hold on a second. Let's kill this guy. Bastard. Okay. Anyway, so at the end of the day, oh no, see, my shields are down now. I'm in trouble, right? And I can angle my shield so that way, maybe I can protect myself for an extra second before I die. Right? Because otherwise, and I also have photon torpedoes. There's different kinds of torpedoes that I can use, unless I die, of course. Okay. So again, when I use the phaser, the line that comes out, which looks like I'm drawing a line, right? I'm really not doing that. In the background, there's invisible bullets that come out. How do they stream from one corner to the other at a different angle? Right, so we'll turn this down for a second and go back to some of this. So let's take a look at phaser tracer. Now this is all up on GitHub, so if you want to take a look at the code, it's there. Take a look at the code with me for a second. So here's phaser tracer. So what is this thing? It is a class, all right? It extends game object, and I have something else. I also implement an interface, because what I can do with TypeScript is also force myself to use different pieces. What an interface is basically I can't inherit from two different classes. There's no multiple inheritance in TypeScript or JavaScript or C# or any of that. I can't inherit from two different classes. What I can do is I can use different piece parts of different classes with something called interfaces. Same thing with TypeScript. It allows you to do that. So I've got this. Basically, I make my tracer. This is what this thing is. Tracer's like a bullet, right? And I have something called calc vector. Calc vector is part now of my game object class. And calc vector, if you want to get the code for how to do angles, right? I want to calculate the new vector, the new position and speed of my bullet every frame. That's what I'm doing. So every time it moves from one position to the next, I'm calculating the vector, right? Okay, so that's some of the stuff I'm doing. Let's take a look at my game object now. So I'm going to my game object really quickly. And if you notice, my game object class, my super class, if you will, is it has a bunch of different things that some objects don't need, right? Like I don't need to make a my button a game object. Can you imagine? It has calc vector, it has bullets, my button can fire bullets. It can, right? But I turn all that stuff off. I don't need it, right? I only use the stuff that I need, right? I know it's a cheesy way of doing things, right? And it might take a little bit more memory, but who cares, right? It does the job. So here's the example of calc vector. So a calc vector says I have an angle in radians. Remember, because in math, when we calculate angles, especially on computers, we need to calculate angles in radians. So I'm going to say take the the direction, whatever direction is. If I put my angle, whatever the angle that I'm looking at, and then multiply that by my pi divided by 180. Once I've got that, right, then I'm going to take this angle in radians. That's what I'm going to. So I'm basically here. I'm converting the angle to radians, whatever the angle is that this person's at, right? And then I'm going to, once I've got the angle in radians, right, I've got to do the calculate my change in x and change in y, which is my speed multiplied by cosine radians, right? It's just I'm taking my angle in radians and using the cosine function to give me the actual new position, the new coordinate on the x-axis, the new coordinate on the y-axis. And then what I'm doing actually for y is I'm flipping the coordinate, because remember, in Cartesian math, normal math, right, my angle, my 0 point is on the bottom left corner, and here my 0 point is in top left corner. So that's why I'm flipping the angle so that it goes up instead of down. All right, so that's this idea of direction and everything else. So where do I get direction from? So direction's a number, right? I'm firing it off, and how do I know what my direction is? That's the other thing. So here's in my constructor, what I'm doing is I'm saying, just like we saw before, width and height, reg x and reg y, all this is normal, right? And then I also keep track of location. So I say, well, this location is equal to a new point, right? I'm creating the point. And I also have a radius, right, of my ship, right? So I know how big my ship is when I try and calculate angles and so on. I also have something called integrity. So my ship's integrity, hull integrity, if you will. So if my ship gets damaged, it's like health. It'll keep dropping from 100% down. So that's what I do. That's why I keep track of my ship. Calc position then, when I do my calculation of position, I say, well, this x is plus equal to this dx, which I've calculated up here. So once I know the vector, then I can calculate my future position. So every frame, my position is going to change based on what I get from my vector, based on speed and position. Right? So if I lower my speed, I'm not going to go quite as far. Because remember, if I'm moving, this works not just for firing bullets, but moving in all directions. Right? If I want to move my ship in all kinds of directions, from a top-down perspective, or a man, or something, I got to use this vector calculation, or else I can only move, unless you want to move in 8 directions. You can do that too. Right, like almost like a blocky movement. You can do that. But if you want to be accurate in terms of realistic movement, where you're moving right and left and so on, not just right and left, but all 360 degrees, you got to use a calculation. All right, so that's kind of math for computers, right? Okay, let me see what else I put in here. Shields up and shields down, turn left. Okay, so when I turn left, I say this rotation, whatever my rotation is, and rotation, by the way, is I can rotate my entire object by giving it a rotation value, right, is equal to whatever the turn rate is, right? So I don't allow a ship to move like lightning fast this way. If I make it, because it'd be too easy. Can you imagine if I go here, and then my turn rate is like 100%, I can turn right around in 2 seconds. It'll be too fast. So I give my ships turn rate to slow them down. So they only move at 5 degrees per frame, or 1 degree per frame, or whatever the hell it is, right? That I gave them. And then that's how I do the rotation when I rotate. One thing to note is when you rotate, right, your boundaries when you rotate, right, as an example, they change. Well, I'll talk about this in a second when I start rotating my ship. Okay, so we'll talk about how if I rotate my ship in real space, in 2D space, my bounds for my object starts to change. Okay, so we'll look at that in a second. All right, so just keep this in mind as we talk about These are just concepts right now, okay? And then what I'm saying is I also rotate my shield. So remember, I have two different objects when I play my game. I have my actual ship, which flies around, plus the shields around my ship, and my shields have to kind of rotate with my ship, right? So my shield rotates to the left. My shields rotate that way too, and I can also fire in that direction, right? So that's kind of a thing to do. All right, so that's kind of a high-level explanation of how this works. I also have different kinds of check bounds. I check different sides of my game, my right bounds, left bounds. I check to see if my ship is approaching any of these boundaries on the board, and I don't let the ship go off the board, right? Because otherwise, if I keep going, you're not going to see my ship, my player anymore. It's going to go off board somewhere, right? So I got to stop it. Right? Now, there's ways of doing this. I kept it simple for my game, right? But certainly, I could have gone to the next level and had a floating board around. So I've got a bunch of these things. This is part of, if you notice, all of this stuff for my game object. This is my super game object that I built. Is all this stuff is part of every object that I use, right? Okay, so that's one. So now let's take a look at my my player object, right, in this particular context. So my player object, again, inherits this game object. That's what it is. It's a game object, right? I also, kind of inherit this I object, which basically makes me have updates and so on. That's all it does. It makes me create an update and a destroy method. That's what it does, okay? So I named the ship just like we did before. I assign controls, right? I call the assign controls method. And if you notice, I use underscores like this for any private method. That's one of my conventions that I've been using, right? Now, you don't have to. I do, because it reminds me. I can look at the, a method like this and say, oh yeah, this method here, that's a private method, without me having to try to search through and see what it is. So I use underscores for that, right? I mean, everyone does different conventions, but that's, for me, what makes it easier. All right, so in my public update, I calculate the vector, I calculate my position, right? That's what I normally do. And this vector that I'm talking about before is just the ability for me to know where I'm going to move next, if I'm going to move at all. I also set in my initialization function, I set my turn rate, and look at this, my config player turn rate. I have a config container class that I use for constants, and player turn rate is a constant that I can change. If I want to make my player turn rate faster, I can modify this constant, and now my player can turn faster, right? I also set my speed to 0, my direction to 90. Okay, my direction to 90. Remember what we talked about from a direction perspective, if I was going to draw it out for you, right? And I'll use this for now so that we can, you know what, let's do Sketchbook Pro. Just because, hey, it's one of the last classes. I'll pull my little pad out. See if it's charged. So let's draw this out for you, if it allows me to. If not, I'm gonna have to plug it in. Yeah, should be dead, maybe. 1 second. Pull up my cord. So what I'm going to do here is I'm going to demonstrate a couple of things. So with when we have our angles, we kind of talked about this before, right? But I want to kind of clarify this thing again, right, for you guys, because one of the challenges that students have for the first time when they learn about rotation in two-dimensional space on a computer, which is a lot different than rotation in Cartesian math, regular math, right? The problem with rotation on a computer is that you're rotating across a different set of axes. Let me take a look here. Connect to Mac. All right, so, right, pad. So what we have here is, and again, I'm just going to take a look at some of these tools. Let's look at we'll use a ballpoint pen for this one, and I'm going to turn up the. Well, actually, you can't with that one. We'll make that one bigger, smaller. Yeah, make it bigger and smaller. I think maybe the ballpoint pen was the best thing. Okay, so let's go and look at a circle. So here's my circle. And again, if you look at this thing, it's just a regular circle. So imagine that your guy's in the middle of the circle, right in here somewhere, and that's not exactly in the middle, but let's just suppose. Actually, I'll just undo that one, and I'll use a point to demonstrate that. So let's say, for example, I have a point in the middle. Sorry, it's a little bit challenging. So here's my point in the middle, and then in this point in the middle, and I know what's happening here. Let's undo that. I meant to do, bear with me guys, it's been a while since I've drawn anything. So here's my circle, and if you notice, if this is my center point in here, as an example, right? Then what we have is different axes. So I have, as an example, I'll just use lines here. This line. I have a line that goes up this way, right? And I have a line that goes down this way. Now don't worry about how thick the lines are for a second, right? So these are my lines of my compass, if you will. So if I was to think about a circle being like this, and I have different positions, right? This top right quadrant up here, quadrant's a really weird thing to talk about, or sector is what it's really called. This top right sector, which is this part of the circle, right? What's the angle? How do I I scope out the angle for all these things? Let me just change my pen to be a little darker, and then make it so it's a little bit smaller in size. I'm just going to choose a smaller nib because it's just too big for me. Anyway, so let's think about that in terms of what this is. So if I look at this right here, this would be the 0 degree mark. So this is 0. Up here is 90, right? And up over here on the left side over here, I'm not sure if you can see this kind of stuff. It may not be coming out so good on the board. So maybe that's why I made it darker in the first place. Because I didn't make it so dark last time. Sorry, make it a little bit bigger. And you know what? I have no choice but to do that. Because you guys won't see it on the board. Sorry about that. So 0, 90, and then this would be 180, right? And this would be 270. So here's 270. So this is 0, 90, 180, 270. So if I'm pointing this direction here, right? That's the direction I'm pointing. For me to go a positive angle, I'm moving this way, up the angle, right? That's not natural for us to think that way, right? We think moving around, if I go to the right, as an example, I think that's positive. And if I go to the left, I think that's negative, right? So this would be a positive turn, this would be a negative turn. But in computers, it looks like this. This is a positive turn. And if I go this way, this is a negative turn, right? But the problem is, take a look at this. If I go to the negative turn, what's happening here? I've got a bit of an issue, right? The issue is when I go under 0, I can't go negative. I can't do a negative 3 degrees or something like that. I can't do that. I have to go from 360 down to 270, right? That's my problem, right? So when I move around when I do angles on this two-dimensional scope, I got to think about moving that way, right? So when I first start off, if you notice my ship, it starts at the 90 degree mark. That's what I make it start off at, 90 degrees, right? And the reason why I want to make it move that way or start that way is because I want to start pointing up, okay? This is east, okay? If you look at the angles, this is north on the compass. This is west. This is south, right? That's another way to look at it. So in the easterly direction here, I would be pointing at 0. So if my ship pointed this way, my angle would be 0. That's my direction, starting off. If I pointed this way, my angle would be 90. If I pointed this way, my angle or my direction would be 180, right? 180. Here's 180. So that's the way it works in terms of my ship, right? Where it's 0, 90, or 180, or 270, or whatever. Let's leave this aside for a second while I go back. I'm explaining this to get you ready for how it works, right? Otherwise, you won't understand. When I do it, you're like, what the hell? What kind of math is he using? Why is he doing that? Okay. So again, my direction then is 90, right? That's what I have in here. And if you guys can't see this, I'll bring it up a little, make it a little larger here. I'll zoom in. So there's my direction. My direction is 90. And again, you can find this all on GitHub. All this stuff, I've got my code on GitHub. You're not going to, lose out here, right? I also start off with my dx and dy values at 0 because Right now, I don't have a dx and dy. I'm not moving initially, right? I also create my target as a new point. Remember, a point is just a class that holds x's and y's, right? So it has a point as an x and a y. So point.x, point.y, that's what target is inheriting. So now I have target.x and target.y when I say it's a new point, right? Photon fired. I have different kinds of weapons. One of them is a phaser. One of them is a photon. Different kind of weapon. It's almost like a torpedo, if you will, right? If my torpedo is fired, I want to keep track where my torpedo is fired. Why? Because I don't want to fire more than one at once. I want to prevent my ship from firing my torpedo more than once. So I fire when my torpedo is on my screen. My torpedo fired is true. I wait, and when it's gone, when it explodes or leaves the screen, my torpedo fired is false, and it allows me to fire my next one. I do that on purpose because I don't want to make my ship ultra powerful, because then I can just fire torpedoes like as many times as I want. It makes it too easy for me. So I may give myself some challenge from that perspective. I also configure the damage that I can do, right? So this is like my damage potential, how much damage I can cause to the other ships. And again, it's based on my on a constant that I have. All right, so calculate target angle. This is one that you'll need to figure out your angle. Okay, so I say, well, this dot dx is equal to this dot x minus this dot target x, right? And my target would be, example, my enemy, right? So, and then this dot y, the dy, is equal to whatever my current position is, 0, minus, this dot target y. So I have the x's and y coordinates of both my ship and where it's going to be in space. Well, let me just erase that. Go back to this illustration here as an example to explain, right? So let's get rid of this. And let me just explain that. So again, on my ship is in this space, right, where I have a map of my object. Just using this as x and y coordinates. So here's my x and here's my y, right? Now remember, x and y on the computer screen looks like this most likely, right? So you have x kind of goes along the top of the axis, and y kind of goes on top, up and down, right? So here's my y that goes up and down, right? Y goes this way. So just get rid of this for a second. Actually, I think I can probably just erase it if I just go back over here. Yeah, there we go. Anyway, so if you notice, so this x and y. So if I'm down here, right? So this is my ship, and it's pointing up, right? And I have my enemy, and he's over here, right? And I want to fire at him, and I want to know the distance. I know that my x and y coordinates, what they are, and if I know what my target my coordinates are, they're x and y. And how do I know that? Because this is an enemy. An enemy has x and y. It's an object. I know. So me personally, I don't know, but the computer keeps track of the coordinates of all objects on the screen, right? That's what I'm making it do anyway. So I know that this is what it is, right? So I know these two objects. And if I go back to what I was talking about here, I say that the difference between x and y, right? All I'm doing is the difference. So what's the difference between my x and my y? Well, if this object in space, let's assign some values here. If my object, this enemy, so here's my enemy object, right? So enemy, right? If this my enemy object is, if my x coordinate is 100, right? So this is where 100 is, and my y coordinate up and down, right? Let's say my y coordinate goes down by 30. So let's say my y coordinate is 30, right? My x coordinate is 100, right? So if it's 130, right, and 100 minus, and if I'm here, and I'm not quite 0, 0 here, because 0, 0 would be up here, right? 0, 0, this is 0, 0 mark. And let's say, if you notice, I'm over here at, I'm going to say that this might be only 20, so my x is 20, but my y value is way down at the bottom. Let's say my y value is 400, right? What's the difference between x and myself? If I'm at 100, the difference is 80. So this is the difference, 80. And my y coordinate is 30 minus 400. Hold on a second. That's wrong. Why is it minus 400, right? Well, 30 minus 400 is, 370, right? But it's minus 370, right? Okay, that's cool, but what do I do with that number? Well, I multiply my y by -1, which turns my minus 370, right, as an example, to positive 370. So this is gone, all right? Sorry, I remember I got an eraser on this thing, except my eraser is really huge. Yeah. Yeah, so that's my my 370. So this is what I got. These two values, 80 and 370. Okay, now this is not the angle. This is just what I need for my angle, right? So if you look at this, calculate target angle. I've got this. That's the first thing. Now, var radians, right? Remember radians. I'm making it it's just a variable that I'm holding. You know, I'm holding my radians in, and I'm using arctangent. Right? That's what it is. To basically take my dx and dy values that I just calculated, right? Put it into the arctangent, right? And from there, I'm going to get an angle in radians right there by my dx and dy values. If I know the distance, I know my x and y coordinates, I can calculate the target angle, which is what you need to do, right? So now I know my target angle, right? And then I want to take my target angle, right, as an example, because remember my target angle is a point. Let's take a look at this, right? When I go back up to the top, target angle is just a number, right? So there's my number, right? So target angle is equal to radians times 180 divided by math.pi, which converts my radians into an angle in degrees, right? And then I take that angle, whatever it is, and I add 180 to it. Okay, and the reason for that is because it'll give me the opposite angle, right? That's what it is. It'll give me the angle where I'm going, but I need the opposite angle. I need to know where he is, not where I am. Not where I am compared to where he is, you know, kind of stuff. So I get the other angle, which is 180 degrees, the opposite side, and then I get an angle. That's how this calculation calculates this angle down here. The angle that I'm going to from this position, right? So if I have a position here to this position here, whatever that is. And if you notice, what I'm doing is I'm using Pythagoras, right, to kind of figure out, because this angle is a 90-degree angle, I can figure out this angle here. That's what I'm doing. This is the arctangent. Remember, this angle is adjacent over a hypotenuse, or whatever the hell it is, right? So that's what I'm figuring out. I know this distance. If I know the x and y coordinates, I know the total number between the difference between one x and the other x. I can figure out the angle. That's what this is. That's what I'm figuring out, this angle here. So now that I know where he is, if I wanted to point my ship to where he is, because I'm pointing up, I can change my angle to where he is. I can modify my angle so I can look at him if I want to. Okay, so I'm showing you how it is in terms of how we figure out the angle. I also talked about how my bounds change. Okay, so when you do this kind of top-down effect, as an example, you should also keep in mind, I'm going to keep this open for a second. You should also keep in mind how your bounds change. Okay, so I'm going to bring up another little tool here. I'll use Fireworks for this. And with Fireworks, right, I'm going to bring up my, I'm going to look and see if I can bring up my, my project. Right, if you remember, I have, in courses, I have my ship, right, which is, let's go back to here. I'll talk about this today as well. I have in my ship, which is my mail pilot, which is somewhere back here. Actually, I can pull any ship I want, but let's go into, that's my slot machine. But my mail pilot, my object for mail pilot is the one I really want to show you. If I could show you this one. That's the other thing I want to show you today. And I do it at different times with different people. Yeah, blue, orange, and yellow. There's my table, and that's not what I want. My roll button. Bear with me while I come up with this thing, because I want to make sure I can show you this stuff. That's not so bad. So let's see if I can do this stuff with Mail Pilot, which Mail Pilot is really, really super important. We did kind of a Mail Pilot project here, KLM pilot, that's pilots. That's my Honda Pilot. Oh yeah, I did a drawing with my Honda Pilot. That was interesting. But I don't have my, for whatever reason, I don't have my Mail Pilot. So you know what? I'll get it from the web, which is pretty good. I have my Mail Pilot assets up there, which I've been working on with you guys, right? And this is really huge right now. But let's move into getting this information. I want to show you something here. So if I go to, if I want to search repositories for COMP397 Mail Pilot, COMP397, here it is. And if you notice, I have some assets here. Here's my images. And this is my plane. This is what I want, right? So I want to I want to see if I can save link as. I don't know if it'll save as a plane, but let's put it on my desktop for now and save it as what it is. And see if I can open it up without it crashing. Of course, it doesn't know what the hell I'm downloading. Right, so let's just download the whole project on my desktop. And I'll just download the zip file onto my desktop, as if I haven't done this before, and unzip it. And we'll go into my desktop, which is right here. Let's kill this. And bear with me while I do this preparation work. Okay, so here's my Mail Pilot project. And this, I just got this off the web, just like I showed you. So here's my images, and I've got my plane, right? So right now, if you notice, my plane is here, right? So let's say I want to rotate this guy. I want to rotate this guy at a different angle. Take a look carefully at his outline. See how is this blue little line here? I don't know if you guys can see that on the screen. You can. This blue line, right, for the plane is his boundaries right now, right? So remember that when we do collisions, right, my center point is the actual boundary. But see the plane the way it looks? If I rotate this guy, so I'm just going to kind of do a rotation. So I'm going to go like this. I'm going to rotate this guy just a touch, right? What happens to his boundaries? Look at this look at this line here. This blue line is the new boundaries, right? If I keep rotating him, right, my blue line is still the new boundaries, right? But see this big line over here? See how this is out of line, right? Right now, this square that's around here is the boundaries of the actual plane. But see how this is sticking out? Guess what's happening here? My whole square, my canvas has to be larger now because for it to display my plane. Because my plane is, look how this is sticking out, especially if I go to the side, like an angle like this, right? If I go to that angle, even though my boundaries are showing up like this, which is different boundaries to bound my plane physically isn't like this. My plane in real life, right, to make my canvas fit, right, it looks now like this. This is my canvas. Hold on a second. Actually, what's happening is my boundaries are much bigger, right, to fit my plane. If I keep rotating my plane, I'm going to keep rotating him as an example, my bounds continuously change, right? So there's my new boundaries. Take a look at my boundaries now. If I point this way, right? So if I use this plane to move around and change direction and make it move in different positions, my actually bounds, the bounds that have this whole plane going, this blue line, this blue box, if you will, it changes size and shape because the computer is trying to box every object that I have. Even if you use point-to-point collisions, you still got to represent your object somehow, right? And the way most times we represent all of our objects with a box. One box, there's another box, and you turn even if you rotate the box, now the box is rotated. It doesn't look the way it does. And it's represented by this rectangle. So if I keep rotating this thing, as an example, let's say I rotate it down. So here I'm rotating it down this way, right? See how the rectangle just got bigger, wider? The rectangle just changed shape. Not this one, not the black rectangle. Don't look at that. Look at the blue rectangle, how it changes shape. Watch. So it's wide, right? And if I keep going, is it wider? Look, it's outside the bounds now, right? And see how my blue rectangle changes again? What if I keep going like this? If I keep moving it, now it's thinner because it's trying to bound my object as much as possible. And that's what happens when you start rotating your ship in two-dimensional space. The bounds of your object and your x and y coordinates shift, right? So when you do your x and y coordinate shift, and also the place where you're pointing, wherever your object is pointing, shifts around too, right? once you start doing this kind of rotation in three-dimensional space or two-dimensional space, what keeps happening, right, is that you have to recalculate your bounds. So remember we do this get bounds method to understand what my x and y and my registration values are. For me to keep my center point focus, I need to use another method, not get bounds, but get transform bounds. That's another method that CreateJS has for us, thank God, right? Because what get transform bounds is it keeps track of our new boundary based on on our rotation, our local coordinate space. Whew. I'm telling you these things because if I don't, you're going to try stuff out and you're going to go, I don't know why, but I can't collide. My collider's not working. I can't calculate my distance. Well, yeah, you can't calculate distance because your old coordinate space has been shifted. I've turned it around, right, on its head. When you transform an object on the computer, you're transforming it. If I rotate it to the right or to the left, I'm physically transforming the object. I'm not redrawing it. I'm not getting a new object that's rotated in this direction. Like for me to do it properly, if you want to, for it to be awesome, look how pixelated this thing is right now because I've transformed it. Did you notice how pixelated it is? Right? This is my little plane that I have in MailPilot, right? I've just moved it around, right? So can you imagine what it does when I try and recalculate as I rotate all this stuff in as I'm playing the game? This is rotating. This is happening inside real time, right? So that's what's happening. It's rotating the whole object and recalculating all of its the drawing points. All of its pixels are being recalculated and redrawn. And if I rotate it often, like I do with MailPilot, do with Starbase 12 with my ship, it has to redraw all that stuff over and over again, which is demanding on the processor. And if I have more than one, like for example, I have more than one enemy and they all rotate too, right? That all those calculations have to be kept up or keep track of. Make sense? That's why I'm telling you these things, so you understand. Before we get into any kind of funky programming today, because I'm going to do some experiments. We got some assets, right? I want to do some experiments with my assets. I got my MailPilot. What if I modified MailPilot so when I pressed my keys, left and right, it turned different directions, right? I want to make a new scene, right? And instead of playing my play, the play scene I want to rotate. I want to move my plane like anywhere I want with my keys. How do I do that? Right. So in order for me to do that, I need a couple of more things added into my game object, which we're going to talk about today. So that's kind of my intro. Let's get to it so that you're not bored out of your skull watching me doing this stuff, so you understand some concepts. And I'm going to do that by getting into Visual Studio. So let's bring up our MailPilot project today. And to preserve what we're doing, because I want to do a couple things here. I'm going to go into GitHub and go into COMP397 MailPilot. I think I have my MailPilot here. It could be the other side. Let's see. Maybe it's on my sandbox. I'm going to put it there now. It is. So in my MailPilot, right, I want to extend this example now. So I'm going to create another state, if you will, right? That's going to replace my play state. So instead of having that game that goes this way, all right, we're not going to do that. Now I'm going to put that aside, and my play state, I'm going to duplicate it, but instead of it going to the play state, I'm going to go to the state where I can control my MailPilot with my keys, all right? As if I don't have my joystick function anymore, right? My joystick's not going to move my plane around anymore. Only my keys are going to move my plane around. Okay, so I need to make a couple of objects. A plane that moves around with keys as opposed to my joystick, right? Because I don't want to kill what I already have. So a different kind of plane, obviously, right? And the second thing I want to do is I also want to be able to move or rotate in any direction, right? So this is using that new calculate function stuff that I have online, right? Calculate vector. Okay, so how do we begin? Well, I know that in my game.ts file, if I bring that up, this is MailPilot, right? I have on the bottom here a couple of states. One I didn't take into advantage of, I just left it for you guys to figure out, is instruction state, which is just using another blank screen and you can put some stuff in. I give you some examples of what you can do. Sometimes what people do is they kind of make a screen in something like a Fireworks or Photoshop. You know, they make a screen, they take a picture of it, and then they include it in their instructions, as opposed to making create.js print a bunch of text on the screen. That's not good, right? So, but now we have our play state, and it's accessing this thing here, which is my play, right? Well, my play state isn't going to access that anymore. So let's just kill this thing for a second. So we're just going to make this go away. And if you follow me with this thing, you'll understand how this all works in a second. Okay, so that's the first thing. So we're changing. We need to get a new state going on, right? Because my state that I'm going to have is just a white background to demonstrate how we're going to move around. It's not going to have an ocean, right? Our plane is not going to be the plane that we have today, right? We're going to use the plane sprite, but we're not going to use joystick controls, or sorry, mouse controls to move everything around. We're going to use keyboard controls, no mouse. All right. So how do I do that? All right. So I need to get a new object going on. So right now my objects I have are button, cloud, game object. I need to use that, right? And my plane. Well, I want to make a new kind of plane, right? Let's call it just avatar. So it's going to be my avatar, right? So it won't be plane or whatever. But it's going to be modeled after the plane class. So what do? I'm going to copy this class altogether, and I'm going to paste it back in there because it is a plane, right? Here's the plane. And I could make it so that it inherits. I'm just going to kind of go in there. I can't call it a plane anymore because it's not really a plane. I could inherit from plane, but there's not much to inherit here. It looks like it's like very similar to this, right? I know it's a game object, but I'm going to call this thing, as an example, just for now, I'm going to call it avatar, right? So it can be any avatar, any kind of object, if you will. I'm going to save this thing and close it so we don't have an error right now. And I'm going to rename this thing down here. I'm going to rename it so that it says avatar.ts. Okay, so avatar. That's going to be my new thing. And I don't have my avatar. And again, the reason why I'm saying avatar, it could be a vehicle, it could be a player, it could be whatever, right? So my avatar.ts file is there. It hasn't been added into my states. It hasn't been added into my index.html. So remember, my index.html binds all my stuff together, right? So if you notice here, I've got all this stuff, all my different objects. It also has my states and all this kind of stuff. And I need to put my object somewhere up here next to plane and island. If I want my game over and my play state and my menu state to know about it. If I don't have any of these, if I don't know any about these stuff, then my object, my avatar won't be known. So let's bring this in. Right now it's exactly the same as plane, so I'm putting it underneath plane. All right, and I'm also going to include this thing the way it is, right, in my game.ts file. I've just made a copy of my plane, but I've just called it something else. I've called it avatar. But right now it's exactly what my plane is. There's no difference. So here it is. Okay, so it's around the same place. And what I want to do, just to keep in line with everything, to prepare for what I want to do, I want to kind of create a global object called avatar, right? Which is of type objects.avatar. There it is. Okay, so I've created my object. I haven't used it yet, right? But I will create this thing. So let's go back into, I don't need this index.html anymore. I'm going to go back into my avatar now. Here's my avatar. The engine sound was cool for my plane, but for my avatar, no, I don't like it. So I'm going to take it out. So I'm not going to make this sound engine for now. And you know what? I don't want my Y value to start at 430. I don't want that either. That means that's the bottom of my screen. I don't want that to happen. I also don't want to play my engine sound. So these are gone, right? But I want to use my plane graphics. It's going to look like my plane, but it's just going to be in one direction, right? My update where it says this.x is equal to stage.mousex, that can't be because now I'll use my mouse to position my plane. So that's not what I want. So I want to kind of redo my class. And this is not my plane class. This is my avatar class. Okay, so engine sound, I don't need that either because it's a public property I don't need, right? So I'm going to kind of kill that. The only thing I have right now is because my game object right now is a sprite, I get a sprite that appears in the screen. And if I was to include this avatar, create this avatar as my main player object, I want it to appear in the top left corner of my screen when it starts launching. So that's the first thing. Okay, so I've got my avatar. It doesn't do anything right now. That's okay. Let's create a new state, right, to hold my avatar, right? Because we have our states and we have my play state. I'm going to do the same thing as I did last time. I'm going to kind of copy this one, Control C. I'm going to Control V, which is going to create my new state. And we're going to call this, I don't know, some kind of state where I move my, we're going to call it the keyboard state because that's what we're doing. Instead of a play state, it's a keyboard state, something else. Or maybe we'll just call it level 2, just to give you guys an idea how it works. We'll call it level 2. There we go. There's level 2. Level 2, even though I've called it level 2, it's still a play state. It still says class play. Can't have that. It has to be called what I'm calling it, level 2. Right? Okay. Couple things I know I don't need. I don't need to update my ocean, my plane, my island, all this stuff, my clouds. I don't need a collision check right now. I don't need my lives to check lives. I don't need my scoreboard. Hey, you know what? I don't need any of this stuff. Right? Well, because I don't have any of this stuff right now. And you know what? I don't need my destroy method because I don't destroy my engine sound. I do need remove all children though, because eventually I will do remove all children. So I'll keep this there and I'll kill that. Okay. I don't need to check lives, you know, right now, so I can kill that too. Remember, I can always get this back because I have it in my play class. I'm using this as a container for what I'm doing. I do need a game. This game container I will use. I'm not going to use an ocean, so I'm going to kill this, or an island, or a plane, or clouds, so I can kill all this. So I want to make my plane look, you know, kind of in middle of nowhere. It's going to float in the middle of space, right? Okay, cool. So I've got my plane, and I want to kind of add in my avatar, right? Because I have avatar as a global object, right? What I want to do is add it in. So I'm going to go avatar, right, is equal to new objects dot avatar. Now I need to pass in a string, and I know that my string is going to be called plane because that's the one that I used in my assets. So if you notice, if I go back to my asset manager, or sorry, if I go to my asset manager, which is here, and I look at and see what it is, I see that I have plane as an asset that I can use. So that's what I'm using. I can also make a cloud, an island, or whatever I want. And maybe we'll play with that. We'll make my avatar an island or a cloud, whatever. You can make it whatever you like. Maybe we'll make a new one, right? But for now, let's leave it as plain. Okay, now that I've got it, I want to add it to my stage. And of course, I use my game container to add it in. So I say game.addChild, and I'll add in my avatar. Now right now, I haven't given it X and Y coordinates, so it's going to appear in the top left corner of the screen. Right, so let's just make some comments here to demonstrate this. And by the way, guys, I think this is a great way to do your little experiments. You want to experiment something, make a new state, clear the screen, make your plane, try stuff out, and then when it's ready, add it in. Right? So instantiate avatar. Okay, good. And add it to the game container. Okay, there it is. That's what I'm doing here. Okay, cool. So everything else should work. I've got my level 2, but I need to add my level 2 into my index.html because it doesn't know about it. There is no level 2 right now. So if I notice right here, I've got all of my states, and you know what? My menu needs to know about my level 2. My play doesn't really need to know about it right now, but maybe it will. Maybe it'll be my second level, right? So I'll put it here for now, right? So I'm going to take my level 2, I'm going to put it in here. There it is, level 2. And I need to also add that in my game.ts file, which is up here, and I want to put it at approximately the same position, which is just above the play, just in case I want my play to know about it one day. Like, for example, if I go from level 1 to level 2, I should know about level 2, right? Okay, cool. That's one thing. So I've got all that stuff going on, right? And I might as well instantiate it here as well, just like I did before. So I'm going to go over here and go var, right, level 2, lowercase, is of type states, right, dot level 2, where I've got that. So I've kind of created my global reference to it as well. So this is my level 2 state. And now that I can go down here, whew, with all that work, if you notice, I've got my play state, right, which I'm not going to. But I'm going to change my play state right now so it goes to my level 2. How do I do that? Well, pretty easy, right? I say something like this. Level 2, or sorry, play, we'll say play again, play is equal to, oh no, I was right the first time. Level 2, level 2 is equal to new states level 2, which means basically I'm just saying that I'm just instantiating my object right here, my new level 2 state, right? Which is now going to be my new play state. And what I'm also going to say is current state function, right, is equal to level 2, right? So once I've done that, I've created all of the things I need. I should be able to move from my menu state into my level 2 right away. Okay, and all I'm going to have is my ship that doesn't move on the top left corner of my screen, if I've done this correctly. If I haven't done it correctly, we'll just take a break. Either way, we'll probably just take a break after this. Let's just take a look and see how this works. So first I'm going to get my menu state, right, with my mail pilot. And then I click play game. And then, boom, my top left corner of my screen, there's my ship, right, exactly like I wanted. Now, right now, I call it my ship, right, as opposed to thing. And I have no control over it. Let's put it in the middle, approximate middle of my screen. So that's the next thing I'm going to do. How do I position it so that it becomes in the middle of my screen? This is easy. I could do that, right? And I know my width, I could calculate my width and height of the canvas. However, I recommend you use a solid number, right? Only because when you start calculating stuff, it's just an extra calculation. And if you know the numbers, you might as well put them in, yeah? So I know my canvas is 640 by 480, which means that's 320 by 240. I want to be right in the middle, right? For now, those are going to be solid numbers. Tomorrow, or later on, I'm going to change those numbers to be part of my config, right? So that I just use a middle screen, right screen, top screen, bottom screen, and I know where it's going to appear, right? Because those numbers don't mean anything to anybody else, right? But for now, let's put it in. So I'm going to go back to this, to my my avatar, and in my avatar, I'm going to have an init function that initializes his position and all that other stuff that I talked about before, right? I don't have an init function right now, but I will put one in, right? And we'll make it so that it's a private method that only my avatar class needs to know about, right? So I'm going to say public, I'll call this private methods, right? Now I only have one that I'm going to implement called, I'll make it private, and I'll call it init. And remember what I said, I'm going to start using my underscore as a convention for all private, anything, private methods, private variables, everything. So I'm going to say underscore, right, init. That's my private method that only works, that's only available inside of my avatar state, right? Okay, cool. So I'm in my init class, and what I want to do is I want to initialize my x and y values. So I'm going to say this.x then is the middle of my screen, which is, instead of 640 is 320, right? And this.y, which is the middle of my screen, which is 240, right? Because that's my, we'll replace these values later on. And then I'm going to call my initialization function from my constructor. When my plane is built, I call my initialization function. So I'll say this dot underscore init, right? And that I'm going to call my initialization function. So initialize avatar, right? Which means start off beginning values, whatever they're going to be, right? I'm starting off in the middle of the screen, and before Ali fades away, I'm taking a break. Just give me 1 second. I know, sorry. It's not just you, it's me, right? It's my fault, buddy. It's my fault, buddy. It's my fault. All right, so let me see what happens now. So here's my menu state. I click play game, and all of a sudden, boom, my avatar's in there, right? So this is the control I want you to have. When you play your game, when you make your stuff off, use experiments like this. Use a state where I can reposition my stuff and play around. It's not a big deal to make a state now that we have the state machine, right? So I've got my avatar. And the next stuff, when we come back from break, is I want to start moving them around with my keys. That's the next stuff we're going to get to. I'm going to use key movements to move my plane around in this particular level, as opposed to my mouse. My mouse won't work anymore. It'll only be my keyboard. And how do I do that? Okay, so when we come back, we'll get to that.